Are you done with?
Mike, was that open or closed circle on 4? Open, because it's not, doesn't have the equal to there, and we go left or right. Right, and remember that rule that Miss Kane taught us. So here's your inequality. Which way would you draw the arrow? If you had to draw an arrow, and it's going this way to the right. Questions on the homework? Anybody from home have any questions on the homework? Okay. This is chapter 4 notes. Just whatever you want to do.
So in the packet, the bottom of page 5, if you're at home but you were in school this week, you should have received a packet from me. If you didn't come to school, the packet was posted online, and we are on page 5 at the very bottom. We're going to look at a little word problem, and then we're going to look at some compound inequalities. So at the bottom of page 5, admission to an amusement park costs $9. This is like, what's the little amusement park?
Canobles Grove.
Canobles Grove, not Kennywood, where you would like pay per ride. There's one in like Meadville. What's that little one called? I can't remember. There's one in Waldamere's in Erie, but there's one from like still going.
Pay with the tickets.
Yeah, you pay with tickets. Yeah. Not right, not too far. I just can't think of it.
You used to be able to buy tickets at Kennywood back in the
Yes,
day.
you did. Yeah, and then they took that option away.
Back when I was a boy.
Yeah. So you pay a little bit of money to enter the park, and then each ride ticket costs $150. So kind of like going to a fair, which I don't even know are there fairs anymore. Like maybe the Butler County
Big
Fair.
Butler.
Yeah, Big Butler Fair. But you
Westmoreland.
pay so much to ride. I know if you go to the boardwalk at Ocean City, you have to buy tickets to pay so much to ride. So the total amount in dollars spent is given by the equation. So they give you an equation. A for amount is 1.5T, $1.50 for every ticket, and then plus the $9 we had to pay to go into the park. Use an inequality to describe the number of ride tickets you can buy if you have at most $45 to spend. So I have $45. I can't spend any more than $45. That's the most amount. In place of A is the amount that I have to spend. So I'm going to go up into this equation and change A to 45. But it's no longer equal because it says find the most amount, or use an inequality to describe the number of ride tickets you can buy if you have at most $45. Well, at most means I can't go over $45. So my number of tickets, and this is weird because you kind of have to look at it as the number of tickets is going to be less than or equal to $45. And I'm going to flip this around so it makes a little more sense. So $1.50 for every ticket plus $9 that I have to pay must be less than or equal to $45 because I cannot spend more than $45. So Michael, how would we solve for T here to figure out the most number of tickets we could buy? And 45 minus 9 is 36. And then, yeah. So what is the most number of tickets we could buy? You take 36 divided by 1.50. 24. And again, keep that inequality sign because that's the most number I could buy. But maybe I only want to buy 15 so that I have extra money to get funnel cake, fried Oreos, a drink, those fresh squeezed lemonades. So I could buy 24 tickets, but I can't buy any more than that, but I could get less than that. So then the question underneath is similar, except it says the admission to the park costs $5. So now I'm only paying $5 and the rides are $1.25. So if I write the same type of equation, each ride is, or each ticket is $1.25. I have to pay $5 to get in. And then I have $45 to spend. So the same amount of cash to spend. So I'm going to say less than or equal to $45. So same amount of money to spend, but it costs less. So I should be able to go on more rides. So subtract 5. And then Michael, you have your calculator. What is 40 divided by 1.25? 32. Again, label that because those are the number of tickets I could buy. So now I can get 32 tickets. So I can go on 32 rides. Or I could save some money for food since I have 45 bucks. Any questions for those of you at home? Any questions on those problems? So we are going to look at compound inequalities today, which are two or more inequality symbols in the same expression or the same inequality, since it's not an equation. A compound inequality is two simple inequalities joined by and or the word or. There are two examples. The one with the word and says all real numbers greater than or equal to -2 and less than 1 can be written as the following. So the inequality that we're looking at has the x in between two numbers. So x must be in between -2 and 1. And if I look at the graph, you can see that x is in between, or my graph is shaded in between the numbers -2 and 1. And that's how we would be shading an inequality. So now it's going to be in between two numbers if the x is in between two numbers. The other option is to have or. Or means you're shading on the outside. So or and outside begin with the letter O. So x is less than -1. I'm shading on the outside. Or x is bigger than 2. I'm shading on the outside. So or, the answers are on the outside, and the answers are in the middle, or in between. We're going to look at a few compound inequalities and try and graph it. So this says solve the and compound inequality. When the equation is squished in between two numbers, it's an and problem. So we have -7 is less than 5x minus 2, which is less than or equal to 8. So usually when you solve an equation or you solve an inequality, you're trying to get x by itself. Well, in the middle here is x. We still want to get that x by itself. So Michael, if you were trying to get x by itself, what would you try and do first? Add 2. So we're going to add 2 to get x by itself. But when you add 2, we have to add 2 to the right side, and we're also going to add 2 to the number on the left, because now there's two numbers that we're working with. So the one in the middle cancels because I'm trying to get x by itself. And then I have to look at the number on the left. Michael, -7 plus 2 is, and the number on the right, 8 plus 2 is 10. So we are adding both numbers on the left and the right. So a little different because this is a compound inequality. Michael, the next thing we would do to get x by itself would be, right, divide by 5. So again, we're still focused in the middle on x. We're going to end up with x in the middle by itself. So divide by 5, but everything has to get divided by 5. So 5 divided by 5 leaves me with x in the middle. Negative 5 divided by 5 is negative 1. So now I'm looking at dividing those two numbers. And I'm dividing these two numbers. 10 divided by 5 is 2. So and is when x is in between. So now we have to try and graph this. So Michael, let's start with the negative 1. At negative 1, there's a less than sign next to it. Would it be an open or a closed circle? Open. So at negative 1, I'm putting an open circle. I'm not going to do any shading yet. Let's go to the 2. It says less than or equal to. So at 2, Michael, is it open or closed? Closed. And then x is in between negative 1 and 2. So we're shading in between negative 1 and 2. So anytime x is in the middle, you shade in the middle. Questions? Anybody at home have questions? So if x is in between, we shade in between. The next example is an OR example. And you can see this is two totally different equations. So it's, or inequalities, use those right words. One inequality or the other. And you need to solve both, but you're solving both separately this time because it's not together, but instead they're separate. So solving 4x minus 7 is less than or equal to 5. I would add 7, but I'm only adding 7 for this one inequality. I'm going to just say solve this one by itself. So my 7s cancel. 5 and 7 make 12. I would divide by 4. The 4s cancel. And I get less than or equal to 3. So that's one answer. But then there's another answer. I have to go to the other inequality. Yikes, saying that word. Equation. We've been doing too many equations, I guess. My 2's cancel. And then I divide by 3. And I get x is greater than or equal to 7. So this is an OR example. Or, we're still looking at those two numbers, but we're going to be shading opposite for OR. So Michael, at 3, open or close circle. And then it says less than 3. So we're shading outside or opposite or outside. At 7, Michael, open or closed. And then greater than, pointing on the outside. So I can see the difference between the two problems. Or is outside and is in between or in the middle. Questions? So there are a couple of checkpoint problems that we're going to look at. The first two are and. So anytime x is in between, it's and. And you need to do the same thing to every piece in the problem. So x is in the middle. I need to get x by itself. So I'd have to subtract 5, subtract 5, subtract 5. 3 times because there's 3 pieces. There's the middle part and then the two numbers on the left and the right. So our goal is to get x squished in the middle. So 4 minus 5 is negative 1. 7 minus 5 is 2. And now I see I have x in between. So that's the goal. At negative 1, we got to label this number line. Oh, we didn't have to label the other ones. Got to label that one. So again, Michael, at negative 1, is it open or closed? Look at the symbol right next to it. And then at positive 2, open. Yeah, both of those are open because they both just say less than. They don't say equal to. And then in the middle, in between, x is in the middle, x is in between. My answers are in between. Those of you at home, do you have questions on that problem? So looking at number 2, if we do exactly the same thing, I need to get x by itself. So it might help to like highlight it or box it. Where is the x? How do I get that by itself? So we have to subtract 8. So the 8 in the middle cancels, and I have 3x. And then I'm going to write both my signs. On the left side, -1 minus 8 is -9. On the right side, Michael, it says 8 minus 8. What is 8 minus 8? 0. That's okay. It's all right to have a 0 there. Next step, I need to get x by itself. Well, right now it's with 3, so I have to divide by 3. So my 3's cancel. I now have x. -9 divided by 3 is -3. 0 divided by 3 is still 0. So we did something in the middle to get the x divided by itself, but then we have to do the same thing to both numbers on either side. So label that number line. This time it says less than or equal to -3. So that's a closed circle. And less than or equal to 0. So both of those are closed. And then again, you're in between, so we're shading in between. Questions? The last two problems, I see the word or. So or is going to be on the outside. And literally, you're solving each of these inequalities by themselves, individually. So I would subtract 3, and I get x is less than or equal to 1. Then I'm done with that one. I would add 6. I get x is greater than or equal to 5. So you're solving them like two separate problems. Solve one problem, solve the other problem. But they do get graphed on the same graph. That's what a compound inequality would be. So you're still graphing them on the same number line. So at +1, less than or equal to. At +5, greater than or equal to. So solid, and then look at the direction. This should be on the outside. Less than 1 on the outside of 1, greater than 5 on the outside of 5. Michael, how would you solve number 4? That number is really... Yeah, we have to divide by -1. What happens when you divide by -1? You're so close. When we divide by a negative, what do we have to do with that sign? Flip it. Yeah, we got to flip that sign. We haven't had any like this in the problems that we've just been working on. Remember, when you divide by a negative, you have to flip the sign. So dividing by a negative, flip the sign. So x is less than -4. All right, there's the word or. So or means I have to then look at the next inequality and solve for that. Add 6. -2x is less than 6. Divide by -2. So again, Michael, when you divide by a negative, the sign flips. So it becomes greater than -3. So look at that sign. We divided by a negative number. When we divide by negatives, we have to flip the sign. So x is less than -4, or x is greater than -3. So less than -4, open circle. Arrow is pointing to the left, so I'm shading on the outside of -4. Greater than -3, well, that's right next to it. So I have these two circles right next to each other. Greater than is to the right, pointing to the right, so I shade on the outside, pointed to the right. So if I compare the two above, I can see that the X was squished in the middle of two numbers. So my shading is squished in the middle. And then in 3 and 4, the X's are separate. So I'm shading separate directions or outside. Questions? That's it. There aren't any other notes for today. Woohoo! So if we travel to Google Classroom, see if we can find the worksheet. Looks like, I think it literally just posted. So you may have to refresh it, but it just posted. It says 10:05 is when it posted. So just posted here. And I'm going to pull it up as well so that we can look at it. But we have a worksheet. The problems that you're doing on this worksheet, I kind of cut and pasted, and I tried to put the number lines above it or below it for us to graph.
Looks good.
Not too bad. Got the number lines got a little crooked, but I couldn't help that. So yeah, Mr. King can do a couple with you.
Anybody from home want to shout out one that you'd like me to do with you? Jason? You just shout a number out.
There's one with a fraction that I just saw, Mr. King. That one might be a good one to go over.
Oh, yeah.
19.
One number 19?
Yeah.
Is that what you said, Jason? 19? Good call, man. All right. So notice that, again, this is an and. So we're going to have to do it to both the left side of the inequality and the right side. So we're first going to start with the -2. Michael, what's the opposite of -2? Yeah, and notice that we're going to add 2 all the way across the board. So 3 plus 2 is going to give us a 5, which is less than or equal to 1/3 times x, which is less than or equal to 6. Now, here's something we haven't done a ton of. How do you get rid of dividing by 3? The opposite of dividing by 3 is, Michael? Yeah, we're going to multiply by 3. So right here, we're going to multiply this by 3, the left side by 3, and also the right side by 3. Michael, what do we get? Can you just go right across? Yeah, 15. 18. Any questions at home? All right, now you look down here and we have this number line. You do not want to start at 0 because it's going to be hard to get 15 and 18 on there. So we could start 14 maybe? 15?
Yeah, 14 something.
14?
Go a little bit below it, sure.
We go 14, 15, 16, 17, 18, 19, 20. And we're going to go and put our circles on our 2 numbers, 15 and 18. Michael, are we putting open circles or closed circles? Good. 15 is a closed circle. 18 is a closed circle. And it's closed because we see that equal to in each of those inequalities. And then it's an and problem. So Michael, do we shade on the outside or the inside? Inside between. You got it. And bada bing, bada boom, that's it. So that's probably the hardest one on here.
Yeah, I think it is. Maybe even number 20.
20 looks a little tough too.
A little different than ones we looked at.
Yeah, it definitely does. Michael, what's the first step here? What do we do with this 2? Yeah, we distribute the 2. What do you get when you distribute? Good. What's the next step? Good. Next step. Good. Do we flip the sign? No, you do not flip the sign because you're dividing by a positive. And again, when we're making these number lines here, I would just put the -5 somewhere in the middle. And then you could put your -6, your -7, -8, -4, -3, -2, -1. So now on -5, is that going to be an open or closed circle? Open. Oops. Open. Are we going to shade to the right or to the left? To the right. Good. Yeah, remember we look at that sign? And which way would an arrow draw? This way. It only has one of them. I'll give you guys a second to copy that down. We still got to get a little bit of time.
6 minutes to get a couple more problems done.
Yeah. All right, call them out. Anybody online have anyone to look at?
So again, you're only doing the problems that are on this worksheet. I kind of cut and pasted some of the problems.
Could we do 8?
Yeah,
Yeah,
100%.
nice job calling it out.
So 8's another fraction. We're going to start the same way by adding a 2 over. So here's the part that we really haven't done a ton of these problems this year.
Not a lot of problems with fractions.
No. 1 over 4 is the same thing as dividing by 4. What's the opposite of dividing by 4? Anybody can shout it out. Opposite of division is?
Multiplication.
Yeah, multiplication. So we're going to multiply each side by 4. These 4s will now cross out, and we'll be left with only the x. And then on the right side, what's 4? We have 1 times 4, which just gives us 4. For graphing these, again, I would just put 4 somewhere in the middle. You just have to put a couple of numbers on either side. You don't have to go, I mean, you don't even have to do all of them. We just want to make sure that you're able to make a little number line. Is it going to be open or closed circle? Anybody could shout it out. Open, good. Left or right? Yeah, there's our arrow. Goes this way, to the left. Very good question. We haven't done a ton of the fractions. All right, if there's any others, shout them out. We'll get a bunch done. Down here, number 2 looked a little difficult. Or number 1, I mean, 21.
No, just one. I don't know, like the first 2 problems are they? Oh, 21 looks good, yeah.
Okay.
You're just cracking those answers.
Let's look at 21. I'm going to rewrite it down here. Remember, we want to get our variables on the left-hand side. So, Mike, what do we do first? Subtract over the... We'll subtract the 3x over, okay? So then we'll get 2 minus 4x is greater than 10. What's the next step? Yes, subtract 2. And last step? Good. Now we're dividing. Notice we're dividing by negative. Since we're dividing by a negative, we're going to flip the sign. So now instead of greater than, x is going to become less than -2. And again, you can just put -2 up here in the middle. Just draw a couple around it, and then on -2 it's going to be open or closed circle. Open, good. Left or right? You got it. All right, any more questions online? I think we could hit the hardest ones. So take the rest of the time, work on it, see if you can get it done, try to submit it right away. Again, this doesn't go into the third 9 weeks grade. So
That third 9 weeks at 100%.
yeah.
Don't
Woo.
forget to submit the homework that was due today as well.
Yeah, let's do that first. All right, if you don't have any other questions, have a good day.
Thanks, you too.
Thanks, Emma.
Oh, look at that time.
Nice. Michael, you got a bunch done, right?